So hello everyone. Today we are going to discuss about DFS. DFS is a depth first search. It's a graph traversal technique where in a C++ and DSA DFS now DFS it's a depth first search. In last lecture we see BFS. Okay, so BFS is a breadth first search, and now is a DFS. DFS is a depth first search. Okay, depth first search DFS is a graph traversal technique. Okay, this is a here you can see in image. There is a graph traversal technique where we go as deep as possible along as a path. Means here only you follow this path. Okay, you can see in diagram. Okay, as soon as possible along a path, as soon as possible, here is a possible at D. Okay, so as soon as possible you can traverse. Okay, so then backtrack when no unvisited node is left, then you can backtrack. But when no unvisited node is left, there is a no unvisited node, so you can backtrack. DFS uses recursion or stack. Okay, here you can see first visited A, then B, then C, then D. After D, there is a node. Okay, so you can get backtrack. So then B has a D. Okay, C has also D. There is a chance, so you can then D, F. Okay, if you choose C, then D, and then F. Okay, when there is a backtrack is possible when there is a no unvisited node is left. Okay, DFS works on a graphs tree, connected and disconnected graphs. Okay, DFS visual example in a graph representation. Okay, first 0, then 1, 2, 3 and 4. There is a adjacent list and adjacent matrices. Okay, so adjacent list in first 0 has a two-way. First visited to 1, then 2, then again 1 has a 2 chance visited to 0 or 3. Okay, 1 has a 2 chances once they visited 0 and then visited 3, but 0 is already visited, so there is a no calculation in a when you write a code. Okay, so they marks visited. If you visited, then it's marked as a visited. Okay, okay, then after 0 you choose 1. Okay, then 1, they have two choice, 0 and 3. Okay, at when backtrack it is possible when there is a no element left node left la. Okay, so then 2 has again two choices, once 0 or 4, but 0 is already visited, so you choose 4. Okay, again 3 has only one choice is a 1, and 4 has only one choice is a 2. Now DFS traversal rule. Start from a node, visit it. If you visited, mark it as a visited. Okay, so compiler or there is a no confusion. If you mark visited, there is a no confusion it's visited or not. Go to first unvisited neighbor. Okay, then same process repeat and then backtrack when stack. Start node 0, visit 0, visited 0, then stack call 0. This is okay. Step 2, go to first neighbor. Suppose you get 0, then 1. Now 0, 1. Okay. In step 3, go to the 3. Go to 3. Here you can see first 0, mark as a visited, then 1, go to the stack, mark visited, then 3, go to the stack, mark visited. Here you can see a stack 0, 1, 3, 0, 1, 3, and there is a mark as a visited. Has no unvisited neighbor, backtrack. After 3, there is a no unvisited neighbor. So backtrack, return to 1. Back at 1, no more neighbors, backtrack, return to 0. From 0, go to 2, 0, 1, 3, 2. Now 0 to 2. Here you can see 0 to 2, 0, 1, 2, 3, 4. Okay, now 0, 1, 2, 3, and 4. Okay, so 0, 1, 3. These are already visited and marked as a visited. Now 0, then second node is a 2. Okay, when you visited, mark visited. Okay, again 2, there is a 4. Okay, 0, 2, 4. If you visited, mark visited. Then DFS travel output is 0, 1, 3, 2, and 4. Means they are not means connected to the neighbor. Okay, they not choice 1 after 2. They go to the depth. Okay, there is a this is a difference between the BFS and DFS. Okay, DFS algorithm is a simple step. Mark node is as visited, print node for each neighbor. If not visited, DFS neighbor. You check if not visited, DFS neighbor. If visited, go again. Move. Okay, here is a code. You can see there is a int v is equal to 5. Okay, so 0, 1, 2, 1, 0, 3. Here suppose 0, there is a 2 choice, either 1, either 2. Then 1 has a 2 choice, either 3, either 0. Okay, then 0, 4, 2 has a 2 choice, either 0 or 4. Then 3 has a only one choice, is a 1, and 4 has a only one choice, is 2. Okay, here you can see. You can use boolean visited. If visited or true, their first stored all elements are false. If you visited, false is converted into true. Okay, and here you can see it's all about DFS and BFS is the same, but there is a means there is a traversal all elements, and it's a same concept, but there is a method is applying method is a different. Here you can means here is a deep as possible along a path, but in BFS you first priority to the neighbor elements, or cover all neighbor elements and then go. Okay, here you can see in a graph. We go deep as possible along a path, then backtrack when no unvisited node is left. If there is a no unvisited left, then you can backtrack. Either you can traversal in deeply. This is a database. Thank you for watching. Please like, share and subscribe.